Good morning. Welcome to the Seaward Roadshow. This is the webinar broadcast version, as you can see from the screens there. Hopefully, everybody can see, and everybody's been able to join us this morning. We've got a good turnout for the webinar this morning, so always good to see so many customers on a sunny Friday morning. So I'm just like to introduce myself. My name is Kevin Smith. I'm category manager for test and measurement equipment at Seaward. I've been in my current role probably about 3 years now, and I've been at Seaward about 6 years in total. So my job is to look after all the product development for our test and measurement products. So that's things like our portable appliance testers, our 18th edition testers, high voltage, solar, all of that sort of thing falls under my remit as product manager or category manager at Seaward. With me today, I've got Donovan Loader, who's our technical support engineer. Donovan's going to be looking after the chat window this morning, looking after your chat questions. So if you've got any questions that you want to cover, obviously raise those in the chat window, and hopefully Donovan will be able to go through those with you. Just looking at the comments there, George just said we've got a captive audience. Yeah, I think we have there, George. I think you're right on that one. I think it's easy to see how we're getting big numbers when everybody's going through the current crisis and working from home from that side of things. Yeah, there may be one or two people I saw. Just seen Anthony there's come on and said that he's got sound problems. If anybody could just post in there and confirm that they can hear us okay and that you can see the image okay, just so we can confirm that it's not a wider issue from that side of things. Just let us know, anybody posting there. Yeah, so James says, yep, we've got a flood of people saying they're okay. So I would assume that it's just local issues from that side of things. So again, just check your computer, obviously make sure that you've got the audio turned on, you've got the right speakers connected and all that sort of thing, and go through. So yeah, apologies for anybody who is struggling. One thing, we are recording this webinar, so again, it'll be posted up on our YouTube channel not long after the webinar's finished. So we'll get that up there today. So anybody who does miss out, you can obviously pick it up again on YouTube. For those of you who are here for the last webinar, the Pat Guard one that I did, unfortunately there was a problem with the recordings on that, so I didn't manage to get that one up. It got some audio but a blank screen, unfortunately. So hopefully we'll have a bit better luck today and we'll be able to get this up on there for you. So yep, that's me. I'm Kevin Smith. I'm going to be taking you through the roadshow today, and Donovan's going to be manning the chat window for us from that side of things. So hopefully yeah, we'll be able to answer your questions and go through. Generally, what we do with the questions, if there's any questions that you've got that are relevant to the content as we go through, obviously feel free to post those and I'll try and address those live as we go through. But if there is anything that's we haven't covered, or any extra stuff you want to do, any Q&A stuff, leave that till the end. Well, post it anytime you want, but obviously I'll leave that to the end, and then we'll review those and go through those at the end of the broadcast, and we'll stay on and do those. So we'll get on with it from that side of things. So really, the idea behind the webinar today was we started our round of PAT workshops sort of February time probably, and we went round and did a lot of these around the country, and went round. We've got I think it was about 13, 14 of these planned across the country, and we delivered about half of those before the coronavirus cut in. And obviously what we've been doing since then is we've been delivering them digitally on this online version from that side of it. So hopefully yeah, we can get to where we are on this side of things and go that. Can we turn off the background music? I don't think there's any background music my end, so yeah, not quite sure where the background music's coming from there, Phil. That's a strange comment, that one. I don't know if anyone else could hear music in there, but it's not me from that side of things. So I've got no music playing here. So as we said, this will probably be about an hour. We're going to aim for, I might be slightly over with the questions, but the main presentation is about an hour. So we'll go through, and I say, if you've got any questions you want to post, obviously feel free to put those in there, or put questions in the chat window, and we'll interact that way round. Hopefully everything will carry on working and we'll be all right. I can see questions flooding in already. That's good to see. So some of you might not know Seaward. Some of you might be very familiar with Seaward. Some of you might not know Seaward, but I'll just give you a brief overview of who we are. We see ourselves very much as market leaders in electrical safety testing. Pretty much everything we do is to do with electrical safety testing, those three words. We've been established 38 years now, since 1982, and we're a British-based company. Something we're very proud of is being a British-based company based up in the northeast of England, in a little town called Peterlee in County Durham, and that's where we've got our factory, and we employ about 160 people up there. And obviously, everything that we sell is designed, made, built, shipped, stored, sold, everything from our little factory up in the northeast of England. So we are a UK manufacturer, one of those rarest of things nowadays, a UK manufacturer. And obviously we do try and source a lot of our materials locally as well from that side of things to keep the supply chain as close to the factory, and certainly as close to the UK as we can. Obviously, some of the stuff necessarily comes from abroad, but we do try and keep as much as we can from the UK. Now, you might well know Seaward, and probably the reason you've come to this workshop is that you know Seaward through our portable appliance testers. And I obviously look after the portable appliance testers, not just in the UK, but globally as well from that side of things. But we also have a range of medical test equipment under the Rigel brand. So the Rigel medical testers, very busy at the moment, because obviously with the current crisis going on, everybody's suddenly interested in testing medical equipment and things like that. So very busy part of the business at the moment, Rigel Medical. We've got a range of high voltage products, we've got a solar range of products, and we've also got our Claire range of products that mainly sit within the manufacturing industry, production line testers, and also are very well known within the higher sectors. So from a Seaward point of view, you probably know us best for our pat testers, and generally, you know, if you think pat testing, you think Seaward. If you think Seaward, you think pat testing. But we have got a lot of these other parts of the business, but all of them are really pretty much based around electrical safety testing. So what are we going to talk about? What are we actually going to include in here? Well, we've put in quite a bit of stuff, and we just call this section really hot topics and myth busting. But generally, there's a sort of overview of a lot of typical pat questions that come up really from that side of things. So where we're going to start off with is where we always start off with pat testing. Really, is just talking about the legal side of it, the legal requirements, and all that. The sort of legal background, the law that goes behind that. So one thing that always confuses people is that pat isn't actually specifically mentioned in the electricity at work regulations. Everybody always assumes that there's the Pat Testing Act 1970 something or other that says we must do pat testing. It's everything with a plug on. It's got to be done every 12 months, and it's a legal requirement, and there it is. And it's not true really from that side of things. The legal requirements that we have, the closest legal requirement that we have that covers pat testing is under the electricity at work regulations, but it's regulation 4, paragraph 2. And we'll come up and we'll show you that in detail in a minute and go into that in details. But it doesn't actually specifically mention pat testing or portable appliances. It just talks about actually maintaining equipment in a safe condition and maintaining electrical systems in a safe condition. There's also a legal requirement for risk assessment. That's an important one under the Health and Safety at Work Act, is actually the ability to carry out risk assessments, and there's actually a legal requirement for employers to carry out risk assessments. So there is actually a stronger case for the risk assessment side of it than there is for the actual rest of the pat testing really from that side of things. And obviously the responsibility then falls on the duty holder. So this person, the duty holder, obviously we're all duty holders, we all have responsibilities under the regulations, but generally we tend to use this term duty holder for the person within the organisation who's responsible. So whether that's the owner, the director, the health and safety manager, whoever it is, the duty holder is this person who looks after the electrical safety within the business, and obviously they need to make sure that they comply with all the regulations, and generally that's done through risk assessment, and then obviously as part of that carrying out pat testing. So we talked about Regulation 4, Paragraph 2, the Electricity at Work Regulations 1989, and it's important to actually read this because, as we said, it doesn't mention pat testing, but there is some important bits in here. So it says, as may be necessary to prevent danger, all systems shall be maintained so as to prevent, so far as is reasonably practicable, such danger. So there's a few things we need to be aware of in there really. The first one is how often do we need to do it? Well, as may be necessary to prevent danger. There's nothing in here that says we have to do pat testing every 12 months. We've got to do it enough to prevent danger. So if we've got high risk equipment in a high risk environment, like a grinder on a building site, we'd expect to do that more often, usually in this case 3 months. And if we've got low risk equipment in a low risk environment, like a PC in an office, chances are we probably would do that less often, maybe say 3 years. So again, how often do we do it? Enough to prevent danger. So from a legal point of view, there's nothing in that that says every 12 months. That's just become again, a myth, a thing that people have just done. Yeah, we do it every 12 months. Really, it's got to be proportionate to the risk. Now, the other thing is, what does it apply to? Now, we talk about this term portable appliance testing and portable appliances, and a lot of people will say, oh, yes, well, a portable appliance, is something like a kettle or a toaster. It's portable, we can carry it around, all these sort of things. Where actually, with the portable appliance testing, people don't think something like a fridge, for example, would be portable. Oh, it's not portable, so it doesn't need doing. Well, actually, in the regulations, if you look at the regulations here, it says all systems. And what it means by systems, this is under the electricity at work regulations, and they design the electricity at work regulations to apply to everything, all electrical systems used at work. So that's everything from a pocket calculator to a power station that's used in places of work falls within the scope of the electricity at work regulations. So the idea that it's all systems actually means that PAT testing doesn't just cover portable appliances. So the name PAT actually confuses people in itself. And generally, if you look at the IT code of practice, it just talks about the in-service inspection and testing of electrical equipment. So we really talk about electrical equipment, electrical systems. So generally, PAT testing, we don't cover the fixed installation, the fixed wiring, but we may well cover equipment connected to the fixed installation, whether that's via a plug and socket or whether that's actually hardwired in. So something like a cooker hardwired in, for example, would generally, if it's in a place of work, fall under the electricity at work regulations and fall under what we, normally call PAT testing nowadays. It'd be fixed equipment testing. But so it's important to understand this idea of all systems does actually apply to everything. It's not just the fact that it's portable stuff and things like that. So all electrical equipment used in the workplace, whether that's battery powered equipment all the way up to fixed equipment, and even the electricity work regs, it's all the fixed installation. So then the duty then is to maintain it. So we've got to make sure it's maintained to prevent danger. We've got to make sure it's maintained in a safe condition. And how do we do that? Well, by doing inspection and testing. Generally, we've got to inspect and test it to make sure that it's maintained in a safe condition. So the legal duty is actually to maintain it to prevent danger. But what we do to check where the maintenance is required is we carry out what we know as portable appliance testing, as an inspection and testing of equipment. So when we're looking at this, we're not just looking at the electrical safety of it. It's not just a quick beep beep on the PAT tester and there you go. Obviously, we'll do detailed visual inspections, we'll do functional tests, all of those sort of things. And we are looking for maintenance. So when you're looking at a piece of equipment, like a vacuum cleaner, how do we make sure it's maintained? So, things like the filters, the bags, the bearings okay? Is it making a funny whining noise? Is it getting hot? All of these things are indication that maintenance may be required. So when we're looking at equipment, we're looking to see, is it maintained in a safe condition? So it's really a maintenance check is what we're doing from that side of things. And it goes on to say, so far as is reasonably practicable. So there's a bit of a balance in there. How often do we do it? Well, we've got to do it enough to prevent danger. Now, enough to prevent danger could mean we're going to test everything every day, but that wouldn't be reasonable and it wouldn't be practical. So again, there's this balancing act, there's this seesaw. We've got to do it enough to prevent danger, but it's got to be reasonable and it's got to be practical. And how we actually make that decision of how often we do it is generally based on the risk. It's a risk assessment. So this regulation, as we said, Regulation 4, Paragraph 2, as may be necessary to prevent danger, all systems need to be maintained so far as is reasonably practicable. And the balance between enough to prevent danger and what's reasonable and practical is where the risk assessment comes in. So again, just a bit of a summary there of the main points that we talked about. So the risk assessment side of things, it says every employer shall make suitable assessment of the risk to the health and safety of his employees to which they're exposed whilst at work. And an important bit here, it says, and the risks to the health and safety of persons not in his employment arising out of or in connection with the conduct by him of his undertaking. bit of a mouthful there, but actually what that means is that we've got to actually take note of the risk to employees. Obviously, that's something when we do risk assessments, we generally think about the risk to employees. But sometimes we think, oh yeah, well, everybody who falls under this risk assessment, they all get an induction when they start in the company. They all know who the first aider is. They've all got PPE. They've all been trained. They've all, we've got training records, all these things. Is all of that true for people who aren't employed? So you've got people like visitors, people like the general public, customers. So again, we've always got to be careful when we are doing these PAT risk assessments, when we are assessing how often to test equipment and what the true risk is posed by equipment, is we do need to make sure that we're not just thinking about the safety measures that apply to employees, but also to people who aren't employed as well. And particularly where you've got businesses that are open to the public, or like a school where you've got school kids in there and things like that, vulnerable people, a hospital, a prison, things like that. You really do need to think about the actual risks to everybody, not just the employees, and that's always important when you are doing risk assessments. So risk assessment is really at the heart of everything we do from a PAT testing point of view. We assess the risk, and then the PAT testing really is a control measure we use to reduce that risk, to actually manage that risk and make it safe to keep that equipment in use in the workplace. So how do we become compliant? Well, again, there's various guidance available. We've got our Seaward PAT guide, and again, the Seaward PAT guide is a great document to download from the Seaward website, and it's like a little mini version of the IET code of practice, really, from that side of things, and it gives you a good run through, or to give a duty holders and users and test operatives a good run through of the whole PAT testing system front to back, really, and it's a good way to start. I'll just take a sip of water. So really, if we want to actually put in place a PAT testing system, we want to put a PAT testing process in there. There's generally two types of system that we'd refer to. And these go by different names, and people know them by different names, but generally we tend to use the term manual systems and automatic systems. So in a manual system, generally testing and recording are carried out manually. So use a very simple portable appliance tester, something like our Prime Test 100. You carry out the testing, and then you record the results down manually. You record them down, with a pen and paper or on a computer or whatever it is. And the asset management and work scheduling are also done manually, maybe with a diary or a calculator or things like that from that side of things. Now the automatic system is obviously taking that to a next step, improving efficiency and getting all those things. So testing is carried out using an automatic, storable, downloadable PAT tester. So you're typing the results into the PAT tester knows what test sequence to do, it automates the test sequence, it gives you a results at the end, it stores the results, you can download those into the software, and as it says there, the asset management and reporting is handled by software. So again, they're really the two options that you've got, and it does depend what level of testing that you're doing. They both comply. They're both ways of achieving compliance, and I think now we've got some slides coming up that will show you just the whole process really from that side of things. So again, choosing which system applies to you really comes down to how many assets do you require to inspect and test. So are you just doing a handful of things every 12 months, in which case a manual system is probably easier, or are you doing hundreds a day? And you really got to get those things there. So how many assets you're going to test, the time that you've got available. So is time a factor for you? Do you mind doing it? You've got to do it quickly, you've got to get in and out, or, can you do it in your own time? Sort of pace yourself a little bit. And also what resource have you got available? Have you got loads of people you can chuck at this, or is it really, tight on resource and you've only got one person, you've got to do all of this stuff and you've got to do it very quickly. That depends on what system you go for. And my colleague Paul, who wrote these slides, has always put a little phrase in here, and he said, remember that the cheapest solution is not always the most cost effective. And what he means by that really is you've got to think about the whole cost. So sometimes you can buy a cheap PAT tester, but actually if it takes you 10 times as long to do the job, then actually it's not a true saving from that side of things. So you do need to look at how it fits in and how the whole thing sort of sits together. So compliance. Now, generally, if we're going to comply with PAT testing, or we're going to comply with actually the regulations, we'd normally put in place a system that looks something like this. And we've put this compliance wheel, we call it, this diagram we've used for a long time to actually explain the process. Now, generally with these things, we start up in the top corner. Now, if we were doing a manual system, this is denoted a manual system, the first thing you always do is you compile an asset register. So you need to be able to compile the asset register. So you need a list of everything. You can't risk assess them, you can't manage them unless you've got everything that needs testing within the workplace down on a list. So that's part of your initial process even of risk assessment, is doing your hazard spotting and working out what do you want to deal with. So once we've got the list, and obviously in a manual system, we'd end up doing that pretty much with a pen and paper. Then we carry out a risk assessment effectively from that side of things. So we'd determine the environment, what type of equipment we've got, who's going to use it. We carry out the risk assessment, and then we define the frequency. And that's generally something we might just put a circle on the calendar, or we might put it in a diary or whatever it is, and just say, yep, we're going to do the PAT testing then. So very basic, simple system. Then we perform the inspection and testing. So you generally using one of our simple PAT testers, something like a Prime Test 100 maybe, or a Prime Test 250, gives you very basic functions. They do actually have automated sequences in there. So when you press test for class 1, it will go through earth continuity, insulation and leakage. So they will go through an automated sequence and give you the pass-fail results from there. But they don't store those results. Those results are just recorded on the screen. It gives you the pass-fails, and obviously then it's your job to record them. So you can do that, again, piece of paper, form, something like that you'd go through. And then you'd probably label the assets, again, so that we know they've been tested and when they need retest, so that any users can identify what equipment's been tested, what hasn't. So we do usually a manual label, so we just write the label out by hand, stick that on. Maintain the records, so we end up with all these big load of PAT testing records, paper records going back to the year dot. And we maintain those records, so when we get new equipment, we add those to the list. Old equipment we take off the list, and that sort of thing. And then the whole process goes round and round and round again, and that effectively is from a manual system. That's generally PAT testing. So it pretty much goes round that process, and you go back. You keep your asset register up to date. You reassess the risks. You perform the inspection and test, record the results, label the assets, and then every so many months or so many years or whatever it is, you just keep going around that cycle, and that effectively is PAT testing. Now, if we wanted to go a bit more of a step above that, so say we've got more than a few assets, then how quickly you can get around this cycle really matters, because if you're actually doing this as a commercial PAT tester, you need to get through that cycle every day. You really need to get through this as you're doing jobs and things like that. So how do we actually speed those things up? So with an automatic system, we can actually use the tester. Now, something like our Apollo tester will compile the asset register. As you're typing each asset in, as you go through, it can automatically give it a number. You obviously type in the details for the asset. You can carry out the risk assessment on the tester, determine the frequency of test on the tester, and it stores all that as you go. So you actually, as you're testing the items, you're building up your asset register, you're doing your risk assessments, you're moving through, all automated quickly within the tester. Now, obviously, to perform the tests, no surprise, you use the tester. That's all automated. You've got all the automated sequences in there. You can write sequences specifically for particular bits of equipment, like a laptop or whatever you want to do. You can program all that in there. Obviously, that then records the results as you're doing it, so there's no need to actually write the numbers down off the screen. So again, that removes a lot of the errors and things like that. Printing, we can use an automatic printer, so we can use a Bluetooth printer, which actually allows you to put on your company logo and things like that. Or we've got a new QR code system where you can actually print QR codes, and then when you come to retest, you scan it and it automatically knows all of the details about the tester and speeds up your retesting. Maintain the records. You then download all those results into our PATguard software, and you can maintain the records, generate reports, move things around, and obviously manage your assets from there. And then when you come to retesting, again, using something like a Bluetooth barcode scanner, as we said, with either just the 1D or the 2D barcodes, you scan the barcodes, and that automates the system even further, saves you having to type in asset numbers even, and then it just goes round and round and round. And you can see how by automating, it just makes that process so much quicker. Now it does depend on what scale of system you've got. You know, if you're testing one or two items every few months, you probably don't need this type of system. But once you start getting up there, once you start getting over a few hundred assets, that's when, you know, you do see the savings at the back end actually come into doing this. But from a compliance point of view, and actually from a Seaward point of view, we have solutions all the way through. We have stuff from our Prime Test 50, a very basic, you know, sort of go, no go pat checker, all the way up to the Apollo 600 with a camera and all the things in there. So it's about getting the right solution for the customer. You know, that's the important thing, is that the customers need to be able to know exactly what level of testing they want, so that they get the right solution. Hopefully, you know, from a Seaward point of view, we've got these solutions that fit in there sort of along the way. So yeah, always speak to us, and we're more than happy to talk to people and do demos and talk about these systems. And you don't have to employ everything all at once. You know, we get customers where they might get a tester like an Apollo, and they're using the Apollo to do the testing. But then at some point they might add on the printing, the barcode scanning, they might add on, you know, some extra test sequences, and the system will evolve as they get a bit more into it, and a bit, you know, sort of more into the skills of how to do it and those sort of things. So it's quite important really that you get the right solution, and that you're able to move, you know, sort of move into that and actually get it dialed into how you want. And really the key takeaway from these two slides is it's workflow. It's not all about the little, you know, the one box here that says perform inspection and testing. Obviously, you know, that's quite a quick bit, but it's the whole workflow, it's the whole end-to-end time. So, you know, again, that's quite important really from that side of things, to actually take all that on board. So additional things just to consider really from that side of things: asset numbering. Asset numbering is quite important, because what a lot of companies do is they'll just number everything every 12 months. So they just, you know, nothing ever has the same number for more than one test. And the problem with that is that if you don't keep a unique number for each item going forward, you haven't got the traceability. You don't know. You know, that equipment could have gone faulty 3 times before, but you wouldn't know, because you just give it a fresh number each time. So it's almost got a fresh record each time. So you're just not picking up any patterns, any trends, any traceability in there. So we always recommend unique asset numbering for items, even if you're using a manual system. Keep the same asset number all the way through, and just make sure that you keep that going, and then that really gives you the traceability that you need for a maintenance history. Because if anything does go wrong, what you need to be able to show is that you've been maintaining it in a safe condition, and you know you've been checking it year on year. And also what keeping the history does is it enables you to inform your risk assessment. So if when you're doing your risk assessment, you can see the records for the last 10 years, and over the last 10 years this item has been absolutely fine every year for the last 10 years, then you can feed that into your risk assessment. You can actually say, well, why are we doing it every year? Let's call it 2 years. Let's check it after 2 years and see. So you can use that history to then inform your test process. And again, similarly the other way around, if you've got a piece of equipment that's actually failed, you know, several times, you need to reduce that test interval. You need to reduce the test interval to make sure that you're picking up the faults as and when they happen. So again, it's important to have that history there. And as Paul's put in there, do we change our car registration number each time we have an MOT? Obviously, we don't from that side of it. So again, it's just making sure that we've got that traceability, and we can demonstrate that we have been maintaining that equipment over time. So things to consider about the risk assessment process. Obviously, risk assessment is very, very important, and we said that risk assessment is really the heart of PAT testing. So when we're doing a risk assessment, the IET Code of Practice lists 7 factors that they recommend that we should consider. The environment. So where's the equipment actually being used? Is it a nice soft environment like an office, or is it a harsh environment like a building site or a farm, or, you know, all those things, a factory, heavy industrial use? Who's going to be using it? Is it highly skilled electrical professionals like yourselves, or is it, you know, school kids? Is it the general public? Is it, you know, hospital patients, prisoners, as I mentioned before, all these sort of things? So the user makes a big difference into the level of risk. Equipment construction. So how is it actually constructed for safety? So is it class 1 equipment where there's an earth needed for its safety? or is it class 2 where the installations improved within the construction of the equipment? Generally, as far as the IT code of practice is concerned, is class 1 equipment is higher risk than class 2 because it needs that earth. So the need to check that the earth is there obviously means that we need to do that testing a little bit more often to make sure it's there. Whereas with class 2 equipment, generally it's seen as having the safety built in, so the testing of it is not as critical as it would be with, say, class 1. Type of equipment. So by type, we mean, is it movable, stationary, portable, handheld? If you think of something like handheld equipment, where's it going to be when it goes wrong? Well, generally in your hand. So from that side of things, again, that's usually the type of equipment that we would check more often. So handheld equipment, particularly things like power tools and stuff, particularly when they're going to be used in harsh environments, are really your more high risk items that you're going to be coming across. Frequency of use. So is it something you get out once a year, like the Christmas lights? Well, obviously there's no point checking them every 3 months. But it could also be something that's, you use every day. And obviously equipment that you're using every day is more likely to get damaged, it's more likely to wear out, it's more likely to require maintenance. So that should be factored in as well to your risk assessment. Type of installation methods. Is it a trailing lead, a cable that sort of drags across the floor and all those sort of things? Or is it a, something that's fixed equipment, so say like a cooker where the cable's tucked away at the back, unlikely to get damaged, unlikely to get disturbed. So the type of installation methods matters. But the most important one of all these, and I've probably hinted at it in the last few slides, is your previous records. Obviously your previous test records, using them to inform your test is a really powerful tool, and you can actually, by doing that, you can actually make your testing more fit for purpose and actually make your test actually fit. 12 months is actually probably the wrong frequency for virtually everything, because it's too long really for high risk items, but it's probably too short for the low risk items. It generally tends to be this halfway house in the middle. So by using previous test results, we can actually tweak our frequencies to make sure that we've optimized the system so that the high risk items are being checked more often, the low risk items are being checked less often. So additional things to consider, obviously the importance of risk assessment from this side of things. So having a system where every asset's tested every 12 months is very common and can have serious consequences. As we said, it can mean that some high risk assets are not looked at often enough, thereby creating a potential danger. Assets that are low risk category be looked at too frequently. And it's really down to the duty holder to actually make this decision. So it's important, this role, again, the duty holder, that within your organisations who is the duty holder. And it should be, somebody who's clearly defined. As I say, technically under electricity work regulations, we are all duty holders for the things that are within our control. But normally within organisations, we'll have one person who's sort of nominated as the duty holder under the regulations that's there to make these sort of decisions. Now, this was one that's I think it's actually topical because I think it's come up in the question box there. I think David's asked a little bit here about competency and that sort of thing. So competency is an interesting one. And there's sections within the IT code of practice that cover test operative competency and things like that. It says test operatives should be competent to inspect and test an item of equipment, and based on the results state that the equipment is safe or otherwise for continued use. Training and experience will both be necessary for PAT testing and PAT tested equipment. Based on the above is the duty holder's responsibility to deem the test operative competent. Very true. This is all covered under Regulation 16 of the Electricity at Work Regulations 1989. And really it says that we should be competent to avoid danger and injury to yourself and others. And the key thing with that is that we need knowledge and experience are both required. So where we put training experience, knowledge and experience are listed there as factors that we need to have. So people often get confused with competence because they say, what do I have to do to be competent? What course can I go on? Can I do a Sitting Girls 2377? Does that make me competent? And actually, there is no such thing as a competency course. Sometimes people may sell competency courses, but actually making you competent is a difficult thing because something like a 2377, Sitting Girls 2377, gives you the knowledge. So it's training, it's a knowledge-based course, but that doesn't give you the experience. and particularly the experience of specific workplaces. You know, somebody like me, I've done a lot of pat testing over the time, as you can imagine. But you take me into a specific environment like a quarry or a mine or an oil rig or a, you know, petrochemical refinery, whatever it is. I wouldn't necessarily be competent to go into those environments. I would need, you know, need familiarization. I need to know the specific risks, the specific hazards, and all these sort of things. So again, it is very difficult to actually say who is competent and who isn't. And actually, there isn't a specific, you know, license to pat test or a competency license, because we can only ever, you know, on a training course, you can get the training, but the experience part has got to come from actual experience in the workplace. So generally, most organisations will have, the duty holder will have a standard that they expect people to do, you know, to achieve. There'll be a certain level of formal training that they'll need, whether that's a, you know, a 1 day course, an online course, a sitting guilds course, whatever that level is for that organisation. But then also they should be looking at the amount of experience that they've had. Is this previous experience, you know, from training records or from a CV where they've actually got a history of, yeah, I've worked and I've done this in the real world? Or is it internal training where they've been mentored and they've been sort of mentored while they've been gaining this experience? And again, it's the duty holder who will have to potentially defend this in court if anything goes wrong. So normally the duty holder would have a register of competent persons along with evidence of the training and the experience that they've had. Now, that said, it doesn't have to be too onerous. You know, if I've got a cleaner and I want to train that cleaner, I want to make that cleaner competent to test their own vacuum cleaner with a very simple go no go tester like RC with Prime Test 50. How much training and experience would that person need to be competent to be able to avoid danger while carrying out that activity? So they're testing a vacuum cleaner in a known environment with a very simple tester. Well, probably half an hour's training, half an hour's experience documented would probably be enough. So to be able to test that equipment in that environment with that tester, the amount of training you need to be competent is quite low. But then you take the same person and you give them a more advanced tester, or you take that same person and you put them into a complex environment like an office and say, right, go and test that. You're a pat tester now, you're competent, go and test that. They wouldn't necessarily be competent in that environment. So that's where the differentiation comes in and where competence is a moving scale. Competence is also a sort of perishable skill as well from that side of things. You know, how do you make sure that you're current? How do you make sure that your competence is still up to date? And that you're actually keeping up to date with these things. And obviously, this is where continuing professional development, things like these webinars and stuff like that come in, where people are keeping their skills fresh, keeping their skills up to date. So, again, a lot of these things is actually quite important to try and keep these things fresh and actually be able to keep up to date and to stay competent. So, competence is always a question we get asked a hell of a lot, really, and I can understand why, because it's a complex scenario, and a lot of times people struggle to actually understand. You know, it's well, you know, if I go and do an online course, am I competent if I did it? And there's different aspects to competence as well. I mean, we do online courses for test equipment user competency to be able to actually use the equipment and know that you can use the equipment. But obviously, that's different from being competent in a certain workplace. And you know, and when you get into complex workplaces, you know, if you're going to start doing fixed equipment that requires safe isolation, that again is a step up, and that's getting closer to the competence level you'd expect to see from an electrician. So as you are testing more complex equipment with more complex connections and different test methods and things like that, that steps the competence up again. So it is a moving scale, and it's really important to get those things sort of dialed in where we can. Oops. There we go. So as we said here, we at Seaward do offer training. I just noticed that we put operative competence and test operative competency and training. Again, from that point of view, competence can only be set up by the duty holder. What we do is we do product training, so we do a lot of product training from that side of things. So it's product user competency courses that we talk about. So we do a variety of courses. We've got everything from our online courses. We've got jumpstart courses to get people set up with new training, with new equipment. We've got pat guard courses. We've got actual on-site courses. And nowadays we're actually doing a lot of online courses, no surprise at the moment. So generally, if anybody wants to improve their skills and get up to date and that sort of thing, obviously you can get in touch with us, and we can talk you through the options that are available from that side of things. But it has got to be a mix. You've got to, you know, have the knowledge side of things, you've got to have the experience and all of that lot, and also be able to use your test equipment correctly. So what equipment is often overlooked? This is the next part of the presentation, really. We have a lot of questions about pat testing, and also, you know, there seems to be three things that tend to get overlooked quite a bit. So first one is fixed appliances. Now, fixed appliances generally, you know, if you look at the definition in the code of practice, it's something that's, you know, permanently fixed in a set position or fixed to a support and all these sort of things. But generally we use the term more nowadays for fixed appliances to talk about something that's not connected via a plug and socket, that's connected to the installation via a cable to a, you know, fuse connection unit or an isolator or something like that. Again, often get missed out, and we'll talk a little bit more about these in a moment. Extra low voltage equipment, so that's the, again, quite often gets miscommunicated as low voltage equipment. So extra low voltage equipment, that's something under like 50 volts AC, 120 volts DC. So quite often battery powered equipment and things like that often gets missed out. And three-phase equipment, again, is another one that we'll talk about. So just going back to the topic of testing fixed equipment, and again, one of the big myths surrounding pat testing is that we only test everything with a plug on. And as we've said, the electricity at work regulation just covers systems. It doesn't say with a plug, without a plug. And generally, if it poses a risk to the user, then we should be doing something to make sure it's safe. And a lot of companies, you know, if you want to know how good somebody's pat testing system is in a company, generally have a look at the things like their hand dryers, the water boilers, the cookers, you know, those sort of things generally are the bits that get missed. And the problem with that is that they fall in the gap between the fixed installation testing, the electrical installation condition reports, the EICRs, and what would be traditional pat testing. So if somebody's doing the pat testing, they'll say, well, I only do the stuff with the plug on. And somebody's doing the fixed wiring will say, well, we finish at the wall, we finish at the fixed wire, we finish at the spur or the isolator. And nobody's actually doing these bits in the middle. And there has been instances that we've come across where, you know, there's been accidents, there's been fires and things like that because of that bit in the middle's not been looked at. And unfortunately, the duty holder is then in a sticky situation because they've missed that bit in the middle. So it is important that we make sure that we're actually covering those items as well when we do our risk assessments to determine who is actually going to test these, because the problem is we get assumption going on. You know, we either assume the electrician does it when they do the EICR, or we assume the pat tester's doing it, and in reality, a lot of the time, neither are doing it, and that's the problems that we've got. Now, testing fixed equipment, generally, testing fixed equipment is harder because we don't normally have the convenience of a plug, which can be used to isolate the equipment and also to attach it to the socket on a pat tester. And generally, the inspection tests we carry out on fixed equipment are pretty much the same as we would do on plug connected equipment, but the key challenges are how do we safely isolate it and how do we actually connect it to the tester. Now, also mentioning on here about competence to comply with electricity work regulations, regulation 16 competence. Those testing fixed equipment must be competent to do so. So just be careful that you actually get to that level where you make sure that you are actually competent to test that equipment, because actually knowing the regulations and knowing how it's safe to do that does require that extra level of training. And I think if you are if you're actually a pat tester and you want to add fixed equipment testing to your portfolio, it's a good opportunity to get some extra training and get upskilled really to be able to do that. And you've got the option, you know, there's a load more equipment there that you can get into, and you can generally charge more for testing that equipment. Also, if you're an electrician who's already competent but you're doing EICRs and you don't include the fixed equipment in there, then again there's another business opportunity for you really to get into that as well. So fixed equipment is something that often gets missed out and often gets sort of, people don't want to deal with it because it's either too difficult or it's below them, you know, it's in that area. But it is something that needs doing, and duty holders really need to get on it. And also people who are doing testing, it is an opportunity, you know, business opportunity there if you get the right skill and if you are trained up to be competent to do so. Now, safe isolation is obviously an important part of this, and you know we're not here to talk about to actually train you up on safe isolation, but there is some useful information. Best practice guide 2 from Electrical Safety First, if you go on their website, actually is pretty much industry standard guidance for safe isolation. So again, it's good to go through and actually have a look and understand what's going on in there. And there is training. Other things we have actually put a video. We've got a video there that Richard Slade's done, which is up on YouTube at the moment, doing very well on YouTube, actually very popular on YouTube. Is just going through how do we actually go through the safe isolation process and how do we go through using the point-to-point feature on the Apollos to actually carry out testing of fixed equipment. Now, it's important to mention that the video isn't intended to be training. We wouldn't want somebody to watch a 5-minute video and then consider themselves competent to do safe isolation, but it is there to show you what's involved with the process, and really that it's nothing to be scared of as long as you've got the correct skills and you're properly trained to be able to do that. And there's some training organisations out there that do safe isolation, very good safe isolation training from that side of things. So yeah, safe isolation is the important part really for fixed equipment, but the testing is obviously similar, but we generally recommend, I mean, this is where the Apollo comes into its own, being able to do the point-to-point tests, just using the croc clips and things like that is actually a really good option from that side of things. So the point-to-point connections with the Apollo, obviously the good thing with the Apollo having the ability to do the point-to-point connections. What I mean by point-to-point is instead of by testing using the 3-pin main socket and one lead, you can put 2 leads in and test between the 2 leads, so it actually gives you the flexibility to test equipment that hasn't got a standard 3-pin plug. So for class 1 equipment, we do an earth continuity test. Quite often this is performed between something like exposed metal parts on the equipment, like the fan there, and also an earth metal part in the installation. So this could even be just the screw on the fuse spur. Obviously you can, if you want to further dismantle it based on the risk and isolation, all those sort of things, further dismantle it, you can actually get in, obviously check on the earth terminal inside, but generally with fuse spurs, due to the construction of them, the screw will always be connected to the main earthing terminal within the fuse connection unit. So a lot of times it's lower risk, and a lot of companies offer this as a low risk, and they do point-to-point testing where they check from the earth point, the earth screw on the spur through to the body of the equipment, like a cooker or a fan or whatever, to prove that there is actually an earth connection and prove that that equipment is earthed. You'd be surprised how often that's actually missed off, where people have installed something and there isn't an earth connection, but because nobody's actually checked the final bit of the circuit, they've checked up to the spur when they've done like an R1, R2 test, but they've never actually checked it to the connected equipment, and sometimes things have been not earthed correctly, or the wrong part's been earthed, or the earth's become detached for some reason. Installation resistance, again, generally we can do the installation resistance test on class 1 and class 2 equipment. With class 1 equipment, it's done between the earth terminal and the line of neutral joined together, and obviously with class 2 it's done between the line of neutral joined together and exposed parts. So exactly the same as we do a normal test on equipment, but obviously in this case it's just using the point-to-point connections there. So that was just a quick run through of fixed equipment, and I say we've got a lot more content on fixed equipment testing and things like that that you can dig into, videos and guides and things. The next section that I want to talk about was extra low voltage equipment and systems. So as we mentioned before, extra low voltage generally is anything under sort of 50 volts AC, 120 volts DC. And it's quite a misconception really a lot of times that people just say, yeah, well, it doesn't need doing, and you'll all see videos where somebody's put a pat testing stick on a laptop and they get ridiculed, say, oh, look, just money grabbing, testing things that don't need testing, all this sort of stuff. But actually as a duty holder, we have got a legal duty to make sure these things are safe. They are systems, they do fall under the Electricity at Work Regulations 1989. And we might not be worried about getting electrocuted by these things, but there's a hell of a lot of, chargers that are catching fire. There's substandard chargers, you get batteries in phones, batteries in laptops catching fire, and all these sort of things. So carrying out a visual inspection on these things and making sure that they are working correctly, that the charger's correct, it's the right voltage, it's a genuine charger, and all these sort of things is actually, it's part of the risk process. It may just be a visual inspection, it may just be a very quick process, but generally everything that's on the asset register, we would want a label on to say that it had been tested, even if that's just a visual inspection to make sure that it's there and there's no signs of damage and things like that. I mean, just going for my own experience, Paul Millard, who wrote these slides, Paul had got a problem with his laptop, and when he looked at his laptop, the battery was actually bulged at the back. There was a charging problem with the battery, and it was actually bulged and it was getting hot. Now, again, if he hadn't done the inspection on that, he hadn't done a user check, he wouldn't have spotted that. And that's just a typical example of one thing. And the more I read up on counterfeit charges, substandard charges causing problems with devices, there's loads of examples of those sort of things causing problems, particularly charges. So it is important that we do check these items, and again, these are things that often gets missed out. In the IT code of practice, they actually say, and I don't technically agree with it, but they actually say that anything under 40 volts, don't bother. Doesn't need testing. Anything under 40 volts, don't worry about it. Now, the problem I worry about is, I've got a circular saw that's 18 volts. That's a very dangerous piece of handheld equipment. Now, am I worried about being electrocuted by it? No. But if it was used in the workplace, would I need to make sure it's maintained in a safe condition? Of course I would. Is the blade okay? Is the guards okay? The interlocks, the stop buttons, there's no signs of damage. All of these sort of things. So quite often, people, when they get even battery-powered equipment, will test the charger, which is generally a pretty safe bit of equipment. But actually, when it comes to the grinder or the drill or the saw or the whatever it is, they're not actually checking that to make sure that the thing's maintained in a safe condition. Because yes, you might not be able to do a historic pat test on it where you plug it into the 3-pin plug and press beep, but you can do a visual inspection. You can check that these things are properly maintained in a safe condition. So it is very important that we do actually check these things and make sure that they're in good nick. So again, this is just reiterating what I've just spoke about there, and it does also go on there to mention lithium-ion batteries. Again, specific types of batteries within equipment, and lithium polymer again is another one, where the modern batteries that we get are very powerful, and if they are mischarged, mishandled, shorted out, whatever, you can get some serious problems there. I've just spotted a typo as well. Devices that use high dentist rechargeable batteries. I think that should be density rechargeable batteries, for example. I'll try and get that one changed for next time. So again, high density batteries, we've got to be very careful with these. We've got to make sure that they are actually the correct batteries for the job and that the charges are correct, because a lot of times it's very difficult to actually extinguish these fires once they get started. They are almost self-fueling from that side of things. So again, just to say that battery-powered equipment poses no risk is not true, and it needs to be thought about quite specifically with your risk assessments and by the duty holder. So actually, this just gives some examples of numbers of deaths from battery fires with hoverboard applications and all these sort of things. And also, now we are working from home and everybody's charging stuff up and all that sort of thing. We do need to be careful of a lot of these things that we've got, and the equipment we've got in the home. Even now we've got home offices and stuff. It is important just to keep an eye on all these things and make sure that we are checking, making sure that everything's safe. And last thing we want is any fires or anything like that caused through these devices, because they can be particularly dangerous. So best practice: make sure all parts of extra low voltage equipment are inspected, not just the bits that plug in. Make sure these additional inspections are recorded, and review the records regularly to identify trends, such as the incorrect charger being used on specific equipment. Generally, I'd try and stay away from substandard or counterfeit chargers as much as you can. It's not always obvious, but generally, if you're buying cheap chargers and things like that, they don't have the same safety precautions in there. Electrical Safety First have done a lot of work on Apple products, and I think the statistic was something like 98% of the counterfeit chargers that they came across had actually got safety faults within them. They didn't actually have the same level of safety protection that was in them. So check that out on Electrical Safety First website. It's well worth a look in there, really, to actually understand about the dangers of these things. So the final bit in this section is talking about three-phase equipment. And again, this is a sort of general misconception that we don't pat test three-phase equipment because it hasn't got a normal 3-pin plug on it and stuff. And obviously that's not true, as we've mentioned time and time again during this webinar. So really, from that side of things, testing three-phase equipment is important. Generally, we would do it using adapters. So we'd normally have adapters from 3-pin through to the three-phase plugs, either the 4-pin or 5-pin adapters. And generally in these adapters, what they do is they connect all of the lines and the neutral, if there is one with the 5-pin, all the lines and the neutral together, and then the test would be carried out in a normal way. So it would do the insulation resistance between the earth and all the live conductors joined together, and obviously earth continuity and things like that are done exactly the same. So yeah, there isn't really any difference to the testing we would carry out and the visual inspections and things like that. But obviously this equipment does generally pose a higher level of risk just due to the, you know, the sort of the power that's there, that's available, and the fact that these things are generally being used in more arduous industrial type environments. So, you know, testing three-phase equipment is important. We also do three-phase leakage adapters. So if you want to do the live leakage tests for the 250, 250 plus and the Apollos, we've actually got an external leakage adapter that you can connect into the mains. You connect the three-phase equipment into it, and then it will actually carry out leakage tests on that. So if you want to actually do mains leakage tests, obviously you can't power three-phase equipment from the pat testers because they only generate single-phase voltages. But we do a three-phase leakage adapter that allows you to do those extra level of tests on that equipment as well. So the next section here was just talking about the types of tests that we would carry out. And actually, this is a bit more of an in-depth look into tests we would carry out to check the condition of insulation. And there is various different types of insulation resistance tests available. It's just really going through the difference between the two from that side of things. So when should we actually carry out the various forms of insulation resistance testing that are available? So what have we got available to us generally on most pat testers? Well, we'll have a 500 volt DC insulation resistance test. We'll have a 250 volt insulation resistance test. We've usually got a protective earth conductor current test, or a touch current test. They're generally known as leakage tests, and the substitute or alternative leakage test. So all of those will tell us something about the condition of the insulation within the equipment and when should we use each one. So the 500 volt insulation resistance test is generally seen as the sort of standard, the normal insulation resistance test, and is suitable for most appliances. The reason I say most appliances there is because we are applying 500 volts between either the earth connection or, for class 2 equipment, exposed metal parts and the live parts within the equipment. Now, it is possible for that to actually damage equipment. 99.999% of equipment is absolutely fine with a 500 volt test, but there is some equipment that is susceptible to damage at 500 volts. So the argument would always be, and I think we mentioned this a little bit further down, is that anything that's surge protected or anything that's sensitive, or particularly anything that's expensive, generally we'd recommend doing that at 250 volts instead. I know people who've tested at 500 volts, you know, every day for years and years and years, never had a problem. I also know people who've damaged equipment by doing that test. It's a very, very rare occurrence, but you do have to be careful because, yeah, the 500 volt test is technically capable of damaging some equipment in very rare cases. So although it is seen as the standard test, generally we'd apply this test to the normal stuff, you know, your kettles, your toasters, your leads, your drills, all those sort of things. But if you've got, you know, sort of an expensive server rack or something like that, you might want to think, or an expensive PC, you might think, yeah, we'll do 250 volt test on this instead, just because it's safer for the equipment that way round. So caution must be taken while doing the test to obviously make sure that we're not touching any parts, because the parts could become live during the test. We obviously also need to make sure that the equipment is switched on, so we're actually testing all the way through to the actual the load within the equipment, and we're not just stopping at the main switch. We're not fully testing the equipment. If we've got equipment that's sensitive or surge protected, generally we wouldn't want to carry out the 500-volt test. We'd probably go down to 250 volts just for that reason. For surge protected equipment, obviously it sees 500 volts as a surge, so you will get some very funny readings if you test at 500 volts. I've been to organisations where they've had surge protected extension leads and they've actually failed them and chucked them away because they failed the insulation resistance test when actually they were doing their job. They were surge protected. And if they'd been tested at 250 volts, they'd have read absolutely fine. So just be careful of that. If you have got any surge protected equipment as well, you will get low insulation resistance readings at a 500 volt test because the surge protection is actually doing its job. And it is easy to mistake that for a fail if you're not careful. And also IT equipment, as long as it complies with BSEN 60950, it should be okay to perform a 500 volts DC test. And again, if we're not sure, we've said reduce that down to 250. In theory, equipment that's tested to BSEN 60950 is flash tested in the factory when it's produced. So because it's flash tested at a very high voltage, the 500 volt DC test should be absolutely fine on that. The only caveat is just make sure it does actually comply with that standard, because if it's counterfeit equipment or if somebody's just put the standard on but they don't really test them properly in production, there is still a possibility you could damage that equipment. So again, go back to the advice before. If in doubt, go down to 250 volts DC. So insulation resistance, 500 volts, our standard insulation resistance test. It's the one we use really on most equipment to check that there's no short circuits between the live parts and the protective conductor or any exposed parts. 250 volts, as we've said really, and we've pretty much mentioned this on the last one. 250 volts, we'd carry out this on IT equipment that doesn't conform to BSEN 60950. We'd also do it on any surge protected equipment or sensitive equipment to make sure that we were getting good readings on that and we weren't causing out any damage. And cannot be used if the equipment can't be switched on without the mains use. Again, what we're saying is we should switch the equipment on to carry out the test. So I don't necessarily agree with that one a little bit on there. Really, we should just be able to turn the equipment on and we should be able to do the tests. I think what Paul's getting at there is if you've got equipment with potentially like contactors or soft starts, things like that, you can't fully test through the equipment because you can't, it doesn't turn on at that point. But realistically, we want to try and turn equipment on. If we can't turn the equipment on, then obviously we can do a 250 or 500 volt test to check up to the switch, but then we'd probably want to do one of the other tests like a leakage test to actually fully test the equipment as well. So protective earth conductor current testing. So what are we doing? Well, basically we're measuring the quality of the insulation by connecting mains to the equipment, and then we're measuring how much of that current actually leaks back to earth, actually travels back down the protective conductor. Now, generally, the way we do this is by measuring the difference between the line current and the neutral current. And in theory, if there's no leakage, obviously the line current and the neutral current should be the same. If there's leakage through the insulation, then we will see a difference between those currents, and that will generally be measured by the pat tester, and it will give you a measurement of the leakage current. Now, again, you can get some equipment where it naturally has leakage current anyway. There might be components between the line or the neutral to earth, and you will naturally then see some leakage in there. Computers and things like that generally have natural leakage currents. So it doesn't mean that the second you see any leakage current that there is a problem, but there are limits. And in the current code of practice for something like portable or handheld equipment, it's 0.75 for class 1 equipment, 0.75 a milliamp. Now, 1 milliamp is about the perception level. That's about where you'd start to feel electric shocks. So 0.75 is below the level at which you'd even feel a tingle for portable handheld equipment, and you could understand that. Whereas other equipment were allowed up to 3.5 milliamps. I mean, still a very safe level. You think that your typical RCD set to 30 milliamps, 3.5 milliamps for a piece of equipment is still a very safe level. But that's what you'd see more typically for things like computers and stuff like that, where there is a bit more higher leakage current in there. So again, actually being able to see the leakage current and understand levels and the safe levels in there. It doesn't just mean that it should always be zero. Equipment quite often has natural leakage currents, but obviously we need to make sure that they're within the safe limits that aren't going to cause any problems. Obviously, when you are carrying out this test, it is a mains powered test. So we are actually turning the equipment on. So if it's a drill, it's going to spin round. If it's a grinder, it's going to spin round. If it's a kettle element, it's going to get red hot and glow. So just be careful when you are doing this thing with the precautions that you take. Obviously, things like drills and grinders, you need to take out the drill bit, take out the cutting discs, all that sort of thing when you do the tests. If it's a kettle, obviously you've got to make sure there's water in it, otherwise the element is going to glow red hot. And take those precautions. It's always something that we would generally recommend doing something like an insulation resistance test first to make sure that equipment is actually there's no obvious shorts or anything like that on the lead maybe before you do this test. But then you've got to be careful while you're doing the test, especially if it's equipment in an unknown condition. You know, if we don't know this equipment's safe to use, we're actually putting mains into it and we're turning it on to get it to run to measure the leakage. That said, it is a very accurate test. It will give you real world picture, you know, of the leakage of that equipment. It actually allows you to turn the equipment on and run it for a period of time. So from that side of things, you're actually getting real world picture of it, whereas something like an insulation test will only measure so far through the equipment. And again, with an insulation test, we're using DC, not AC, so there can be differences in readings that way around. So protective conductor current tests are very good, very accurate tests. Generally used, as it says there, for class 1 equipment because it's got a protective conductor. You can't do these on class 2. And another thing to be aware of, just the final point there mentioned on the slides, is just be careful if you are turning these things on for the period of time you set the test, the duration to, because if you've got something like a computer and you set a 5-second test, it'll just start booting up, spins the hard disk up, and then you yank the power out. It can cause damage sometimes to things like hard disks. So just be careful when you are doing these. You might want to extend the time period if you're doing these tests for sensitive bits of equipment like that, to just give you enough time to turn it on, boot it up, shut it down again to actually measure. And you can adjust that generally in most of the testers. You can adjust the test times for those. So protective conductor continuity test is, I say, it's another way we can check the insulation, but it's by applying the mains voltage to it. Touch current is very similar, and I think a lot of these bullet points are exactly the same as with a touch current test. But touch current is generally the test that we do on class 2 equipment, although it's not exclusively for class 2. We can do it on class 1 if we wanted to, but generally for class 2 equipment, we do a touch current test. And instead of measuring the current coming back down the earth wire, what the touch current test does is it measures the current and simulates what would come back through me if I were to touch, for example, a certain screw head. So instead of using my finger, we're using a test probe to touch a certain screw head. And what it will do, it will measure the test current that would come back down that screw. So if I was going to touch it, what would I see? Would I see any current? Would I see a low level of current, etc., etc.? So we can use that to test at various points on the equipment and actually carry out a touch current test to make sure that accessible surfaces are actually safe and that we're not getting any dangerous touch currents present on those surfaces. Again, it's a live test. We are powering the equipment up, we're running the equipment, so we've got to be very careful when we're carrying out this test, because equipment is running up, it is getting, sort of getting hotter, it is actually spinning around or whatever. So again, we've got to be careful on the safety precautions, the PPE and all that sort of thing that we might need to use when we're doing it. But it is a very accurate test. It will tell you, is that part safe? Is that part got any dangerous touch currents on there? So again, very useful test, but needs to be done and understood as part of the mixture of other tests really in there, and maybe done alongside something like insulation resistance first and things like that before you carry out these tests. Final one to talk about is the substitute or alternative leakage test. The substitute or alternative leakage test, basically, when we're doing this test, it actually simulates what you would do if you were doing a normal leakage test. So if you've got purely battery powered equipment, you can't put mains into the tester. You can't add 230 volts, 240 volts to equipment. And maybe you don't want to, maybe you don't want to power equipment up because it would be dangerous and you can't do it in that environment or whatever. So the substitute alternative test is a test we can do, but it actually does it at an extra low voltage, at a much lower voltage. So typically it does this at 40 volts AC. So what we do is we put 40 volts AC into the equipment, and we put that in between the line and neutral joined together and the protective conductor, or for class 2 equipment, the line neutral joined together and exposed surfaces, pretty much like the leakage test or the touch current tests. And then what it does is it measures the leakage at that voltage and then scales it up. So for example, if it saw, 1 milliamp at 40 volts, it would scale that up, effectively times it by 6. So what would it be at 230, 240 volts? So we presume then that we'd see 6 milliamps if we got up to there. So again, there's a scaling going on in that process to actually to get to a simulated result. So it is a very good test actually, because it allows you to do a leakage test. Unfortunately, not past things like, obviously you can't turn on things like soft starts, relays, contactors. So it is only checking the input side of the device really. But it's giving you an AC measurement. So I said to you before, there is a difference between AC and DC. And if we've got capacitive leakage, the AC test or the substitute alternative leakage test will pick up those leakages as well. So you actually get a better picture of how it's going to perform when you actually apply the AC mains to it from that side of things. So this substitute alternative leakage test is a very useful test. And we apply this using the battery powered testers, and actually gives us an alternative really to the other tests where we can't perform the other tests and where they can't be carried out. So the options that we've got then for checking the insulation is 500 volt insulation resistance test, 500 volts DC, 250 volt test. We can do a protective conductor current test, we can do a touch current test, or we can do a substitute or alternative leakage test. All of these things will tell us about the condition of the insulation, and generally it's about understanding and applying the right ones at the right time to actually, have we got the right test for the right job to give us that picture of the insulation. Now, ideally, we do all of them, let's do them all, but obviously, it's this reasonably practicable. What do we need to know to actually understand the faults posed by the equipment? And generally, that's where most people will generally pick one or two of these tests to carry out on equipment to make sure that we're getting that information and we're making sure the equipment is safe for continuing service. But it is very much a menu of tests. You can apply one of them, you can apply all of them, and you can get a good idea of how the equipment's performing. And yeah, so hopefully that's been a little bit of use there just to explain to you the differences in the test that we've got. So RCD testing is another important part of testing, just to make you aware of. And in the code of practice now, we are required to actually check things like the tripping times. It used to be we just press the test button on the RCD and there we go, but now we are required to actually carry out the tripping time test. So things like the Pointtopoint 250 Plus have got the RCD testing. Obviously, the Apollos have got the ability to carry out RCD trip time tests in there. So if you are testing equipment that has got RCDs, or you are coming across RCDs, obviously just think about that when you're selecting the right tester to get, that you can actually perform the RCD tests. So that's pretty much gone through the myth busting and the hot topics really. I know that was quite a quick run through. Normally when we do a workshop we sort of take about 3 hours to go through all this stuff, whereas actually we've gone through this stuff quite quickly there. Just about an hour. Now, finally, what I just want to talk to you about is how that applies to some of the pat testing solutions and hardware and things we've got, and the differences that we've got in there. Now, just to make you aware, is we do actually have a pat testing guide available, and we've actually got an animated guide on the website, a little flow chart where you answer questions and it takes you through which tester's right for you. So if you're not sure whether you should be going down a manual route or you should be going down more the automatic testers, we've actually got a live tool on the website that can help you go through and select. And we've also got our choosing the right tester guide as well. It's free to download. But there is a little online tool that we've got on there that you can just click and answer the questions, and it takes you through the process there. So as it says on the slide, most pat testers, or all pat testers, will do earth continuity and insulation. So why do some cost a few £100s and some cost over £1,000? And this is really what we're going to talk about now. So there's loads of things you need to consider when you're actually doing pat testing. We mentioned how many assets have you actually got. Do you need to be able to do a 250 volt test? So have you got sensitive equipment? Have you got surge protected equipment? Do you need to do a 110 volt test? Or do you need to be able to test 110 volt equipment? Most of our pat testers will do a 110 volt test using adapters, but if you want to actually do a mains powered 110 volt test, the leakage tests and things like that, again, you're looking towards maybe our Seaward Supernovas or maybe towards our Clare range of hire equipment. Again, do you test equipment after repair or do you hire equipment, in which case you might need flash testing depending on what code of practice or what standards you're working to. So again, that maybe moves you more towards our Clare range of products that are suitable for the hire industry or manufacturing. Do you need to be able to test portable RCDs? As we said, things like our 250 Plus and our Apollos give you the ability to do the RCD testing. Testing equipment with long leads. Obviously, all of our testers will test equipment with long leads, but if you've got something like a Prime Test 100, it may fail anything that's over 0.2 of an ohm because it sees the long lead as high resistance and it just says fail. Whereas on the Apollos, you've actually got the ability to do a limit calculator and actually say, how long the lead is, what the resistance reading should be, and then you can actually calculate that. So again, if you're coming across those things more, then maybe you want to go to the more higher end testers because it gives you the flexibility to allow for that. Do you need to do the mains powered test like the touch current, protective conductor current that we talked about? Our battery powered testers like the 50 and the 100 won't do those. They'll do alternative leakage tests, but they won't actually do the mains powered tests. Do you want to download results or fill in by hand? Again, the difference between the sort of prime test range of testers, the manual testers, and then going up to the Apollos, the downloading testers. Do you want a label printer and barcoding? Again, that means you're getting more towards the Apollo end of testers. Do you want to inspect and test other items like ladders and other non-electrical equipment? It's an interesting one actually because with the Apollo 500 and 600, you've got the option to put in non-electrical tests. So you can actually write any inspection and test sequence you want in the tester. So if you want to do a ladder inspection, you want to check fire extinguishers, fire doors, vehicle inspections, PPE checks, anything like that, you can write those sequences, and anything that's a number, a value, a tick box, you can create a sequence and record that data using your Apollo 500 or 600, or sorry, 500 plus, 600 plus. And you can download that to PackGuard report on that and treat those the same as you would with any other asset really from that side of things. So all of these are important things for you to think about really when you're actually going through and selecting what is the right product for you. So I'll just go through very quickly just the range of testers that we've got on here, starting with the Pointtopoint 50. Pointtopoint 50 is a very basic battery powered, and it gives you a ticker across, as you can see on the screen there. So it's ideal for doing what I call enhanced visual inspection. So if you're getting new equipment and you just want to do a check on it before you put it into service, but then it's going to be checked again as part of the main pat testing, maybe annually or something like that. If you're an IT technician and you just building up a desk for somebody and you're putting leads in and things like that, you might just want to do a quick check, make sure it's all safe when you've left it. If you're a vending machine installer and you want to check the device before you leave site, if you're a white goods installer, similarly, once you've taken it off the van and unpacked it and stuff, do you want to just give it a quick test? That's where the Pointtopoint 50 is great for doing that. Very simple. You don't get any sort of values. It's just a quick pass-fail indication and really, really quick, simple testing. Pointtopoint 100 is similar, but you do get the values this time. So again, you can actually see battery-powered, really popular product, this one. Battery-powered tester gives you everything you need on there. Quick 3-button operation, class 1, class 2 or lead. You can also check mains voltages with this. So if you want to put a lead in, you can actually check a socket outlet and see what the mains voltage are coming out of a socket outlet, things like that. So great little battery powered testers, and these really are the heart of our manual testing solutions. So for somebody doing low volume tests, happy to record the results by hand or maybe using our new Seaward Pat mobile app. Again, that's brilliant options. Pointtopoint 250 Plus, next step up again, gives you mains powered testing, gives you RCDs, 250 volt insulation resistance. So really the full suite of things that you'd want to be able to do with this. And also you can add on accessories like a printer to this, so you can get a serial printer, and you can store up to 999 results in there. Obviously, you can't put things in like site location, asset description, but what it does, it will allow you to just download a spreadsheet of your results, and then obviously you can open the spreadsheet and type in the information into there as you're going. So yeah, it's a very simple way of storing the results there, and it's sort of not quite a fully downloadable tester, but it does actually give you some form of result storage, and you're able to use a very simple spreadsheet and printer. The Apollos, obviously entry level is the Apollo 400, starts off, that's just a basic tester design for pat testing really. Stores up to 2,000 records and gives you the downloading and the test sequences and all of the good stuff that you get with your Apollo range of products. Going up to the 500 ups the amount of memory capacity and also gives you the ability to do these sort of user checks. So the user-defined test sequences like your PPM and ladder checks and all that sort of stuff in there. So the Apollo 500 is really popular with pat contractors where they're a bit more focused on the sort of performance side of things and being able to use it. And then the sort of flagship product is the Apollo 600 Plus, and the Apollo 600 gives you up to 50,000 records. It's also got a built-in camera. It's got additional health and safety tools built in there, and you know, there really is all the extra functionality in there. USB memory port slot, so you can put a USB memory stick in and things like that. So again, that's really going up to the top end of the products we've got. So you can see from a Seaward point of view, we've got solutions all the way from the basic pat checker, the Pointtopoint 50, all the way up to the Apollo 600. And we're really happy to, you know, to help you find where within that process you go to and where you naturally fit within that. We've also got kits and things like that available. So just be aware, if you are buying the products, quite often it can be expensive if you buy the tester and then you want to buy a printer, then you want to buy the software, then you want to buy and you add all these things on afterwards. Sometimes it is better, you'll get a better deal if you actually buy a kit to start with, because what we do is we can spread the cost out across all of the products within the kit, so we can make the kits a lot more cost effective than if we were doing them separately. So always have a look at the kit options that we've got available. If you're thinking of buying anything, it's always a good idea to have a look at those, because sometimes while you actually go into the, you know, you're getting the purchase order, you're getting approvals and all that sort of thing, sometimes it's as well to get all that lot bought in one go, and then you know you've got everything that you need. You're not going to sort of start doing it and then find, oh, I wish I'd got one of these, or I wish I'd got one of those. You know, you get the kits and everything's there in one go. We've also got our Pat Mobile app. So our Pat Mobile app was launched towards the tail end of last year. Unfortunately, at the moment, only for Android, but we are, lockdown permitting, we are currently working on releasing the iOS version. Obviously, lockdown's affected that a little bit at the moment, but we've currently got the Android version out there, and I think we're you know, creeping towards 1,000 users now. So yeah, there's actually it's proved really popular from that side of things, and we are working on making improvements to that as well based on customer feedback. So yeah, we have been a little bit delayed in the process of this, but there is lots of people out there using it, and it is a great addition. You know, it's a free app. It's a great addition to manual testers, and it just gives you the ability to actually create your results, store your results, you know, print, scan barcodes, take pictures, and output into some great looking professional PDF reports and CSVs and things like that as well. So definitely worth taking a look at that one, and it is something we're actively working on at the moment, and hopefully, you know, once we get through the lockdown a bit, we'll be able to get the iOS version out and some more updates as quickly as we can. PatGuard software, obviously PatGuard is our main pat testing software, and it's a great solution for anybody who's got the downloadable testers, because really when you've got a downloadable tester, to unlock the power of those, you've really got to have the PatGuard software to be able to get all of those results, create all the reports, and actually manage your pat testing records, and really get to that level where you can automate your workflow and actually be able to get, you know, your test results, your reports, your retesting, and all of that sort of thing managed in there. The great thing about PatGuard is it's a free download for a month, so there's no real reason why not to go on, download it for a month, have a trial. It's a fully functioning trial. See if you like it, see if it works, and if you like it, then obviously you can purchase that. PatGuard runs about £120 a year for the 1 year license. Obviously, we have got an outright license as well, which can work out more cost effective from that sort of things. But the most expensive option would be the one year license. So £120 a year, £10 a month, really, for somebody who's doing professional pat testing. I don't think is too bad, really, from that side of things. And obviously, it gives you the ability to actually create the reports, store the results, manage your assets, do risk assessments, and all of that good stuff that goes with the PatGuard software. So again, feel free to go on the website to download that and give it a try, and obviously get in touch with us from that side of things if you need any support. So in summary, again, just going back to what Paul's been saying there, remember, not always the highest cost solution is the most expensive, and not always is the lowest cost solution the cheapest. You need to think about that whole compliance wheel and the whole process, and really look at where you're sitting within that. So what's ahead? Now, last little bit on here just to talk about the 5th edition Code of Practice. We're currently on the 4th edition Code of Practice from the IET. The 5th edition Code of Practice is due to be coming out later in the year. We've just had the final versions come through now from the IET committee, so it's due to be published, we think, probably July time. So maybe towards the end of July, again, coronavirus permitting, we'll get a new Code of Practice that comes out at that point. So we had the public consultation for this was sort of ended in September last year, and we've gone through a lot of the committee comments and things like that. I've been lucky enough to sit on the committee and go through and actually see all the changes. So not too many changes, but there's a few things we need to be aware of, particularly around risk assessment, and there's a few new areas we've put in, like rack-mounted equipment, and there's a lot of changes to the book. So again, keep an eye out for that later in the year. We're going to be doing a lot of webinars. We're going to be doing a lot of content. We're going to be updating all our materials and things like that, and maybe make some changes to the testers and things as well. So keep an eye out for the 5th edition content. We're going to be doing a lot more on that later in the year. That's probably looking to come out about July time. So keep an eye out, and obviously we'll be bringing out a lot more information about the 5th edition as we go through. So a few of the little changes just to mention on there. Section on the law has been made simpler. A lot of things have been sort of simplified. The whole layout of the book's really been simplified. The removal of the classification of equipment. So generally things like portable, movable, handheld and stuff has just gone. Even portable appliance has gone, because as we've talked about, it's all equipment. It's all equipment from that side of things. So there's a lot of terminology changes and things for us to get to grips with. Further reinforcement of the requirement for risk assessment. There's a bit more stuff in there about counterfeit equipment. Table 7.1, the frequencies. The frequency table's now gone. It's all based on risk assessment. So again, there's a lot of stuff in there for us to get our heads around, and we'll obviously be providing you with the content on that as and when it comes out, and we'll talk to you more and more about that as we go through. So keep an eye on seaward.com/events, and obviously if you're subscribed to our emails and social media, then you'll get the updates on that as and when it comes out. But we'll be doing a lot of content on that when it comes